In this tutorial, we'll learn how to answer the questions on homework number 5, but first, a little bit of background. So in earlier grades, you start solving equations that look like this. And you use inverse operations to isolate the variable, and you get your solution, right? So this is what we call one solution, where the number 7 can be substituted in for the letter x, and that is the only number that would work. 7 plus 3 is 10. No other number will work. 5 plus 3 is not 10. 2 plus 3 is not 10. So this is known as the one and only solution. Then we start making our equations a little bit longer, like this. Okay, and you started isolating your variable by using inverse operations on the variables. And then we got something like this. And then we isolate by subtracting our constant, and we get x is equal to negative 11. Again, there is our one solution. And then we got some special cases, like this. X plus 3 equals x plus 3. And some of you notice right away, hey, the left side and the right side are a match. So whatever I plug in here, I also have to substitute in there, right? Because they're the same variable. So if I substitute in the number 5 here, I'd have to substitute the 5 there. That's a true statement. 5 plus 3 is always equal to 5 plus 3 because 8 is always equal to 8. And if I had x plus 3 is equal to x plus 4, and I had to substitute in the same number here, like let's say 5 plus 3 and 5 plus 4, well, 8 is never equal to 9. Right? So these two situations are known as infinite solutions and no solutions. So infinite solutions happens when any number can be substituted for x and it will work. And no solutions is when any number that you substitute in will never work. All right, so let's go back to that beginning. If I have x plus 3 equals x plus 3, that's infinite solutions. But if I have x plus 3 equals x plus 4, that one was no solutions. So do you see what's similar and what's different? In infinite solutions, your left and right sides are a perfect match. Your variables are the same, and your constants are the same. But in no solutions, your left and right sides are not a perfect match. You have the same variables, but you have different constants. So that's what we're going to be working on in this lesson today. Can you make structure here, use of structure, in knowing that when the variables are a match and the constants are a match, that's infinite solutions. When the variables are a match and the constants are different, that's no solution. And when the variables are not a match, like this, that's no solution. I'm sorry, that's one solution. That is one solution. Because no matter how much manipulating I do, I'm always going to have an x left over somewhere. So let's take a look at the first topic here. Complete the sentence based on the equation shown below. 4x plus 4 equals hx plus 4. So this h is a mystery number. And so now we need to figure out what number is going to go there. Well, it depends on what they want. This equation will have one solution. Do you remember what I said before? The only way you can have one solution is if, remember these two sentences, right? Perfect match, infinite. Mismatch, no solution. And then this one, can you see that? Where the coefficients of the variables, they're totally different. But these, they're exactly the same, right? Exactly the same. So we are looking for a variable, a value for h where it's going to be different than the left side, right? If you want a solution, then the value of h has to be different. Now you can pick any number you want. Any number will work, so I'm going to pick 7. And I know that I'll get only one solution because when you have a different number of x's on either side of the equation, then you're going to have one solution, and it doesn't matter. These constants don't matter. They can be the same, they can be different, doesn't matter. But as long as you have a different number of x's, you have one solution. Let's try this again. All right, let's see what they want this time. This equation will have one solution. So do you remember what that means? That means that your x values have to be different, right? You have to have different x values. You could put any number you want here. Anything will work. I'm going to put a -2 here. And I know that will work because when my x values are different and my constants don't matter, then I'll get one solution. All right, we got a different question this time. It says complete the sentence based on the equation shown below. 9x plus 4 equals something x plus 4. And this time they want infinitely many solutions. Well, in order for that to happen, your left and right sides need to be an exact match. So that means that the missing coefficient here has to be a 9. And we want that because when you have the same number of x's on either side and you have the same constants, then you are infinitely many solutions. This equation will have 0 solutions when your coefficients here are a perfect match, yep, but your constants have to be different. So we need to pick a number here that's different than 4. So I'm going to put a 7. And that's because when you have the same number of x's, but different constants, it's not possible. It is no solution. All right. Now let's upgrade this a level and take a look at the second topic here. Complete the sentence based on the equation shown below. I have a 3x minus 6 and an x minus 2. Okay, those are totally different, but this 15 would have to be distributed, right? So if I distributed that 15 over here, I would get 15x minus 30 on the right side. And now they want me to distribute something over here so that I have one solution. Now that means that this x value has to be different than 15. So I can be any number I want, but not 15. So I think I'll put a 2 here. If I put a 2 in the h position, I'll get 6x minus 12. And as long as I have different x values on each side, then that will result in one solution. So I'm going to put 2. I can pick any number I want as long as it's not a 5, because a 5 times 3 would be 15. You will get that one solution when you have a different number of x's on either side and the constants can be the same or different. It doesn't matter. Let's take a look at another one. They want us to have one solution here. They want us to have one solution. So the right side has negative 15 as the x. So the left side has to have anything but not negative 15 for the x. So if I put a 5 here, that would give me a negative 15. So I can pick any number that's not a 5. Any number that's not a 5 will work. Any number that's not a 5. So I'm going to pick a 2. And that's because you will get one solution when you have a different number of x's and the constants don't matter. They can be the same, they can be different. One last time, they want one solution here, so I need x's that are different. So I need this to not be an 8 after I distribute, right? You're allowed to distribute something here. I need to make sure it's not an 8, so I don't want a 4. Anything except 4 will work. So let's see, I'm gonna pick 6. And that will work because I have a different number of x's and the constants can be the same or different. Alright, last one. This equation will have infinitely many solutions. Remember, infinite solutions are when the left and the right side are perfectly the same. Same x's, same constants. So, over here, I have negative 8x and 8 with nothing to distribute. So over here, I need a negative 8x plus 8. So I need to distribute something here that will make this turn into a negative 8. And that would be a 2. So the only number that will work to give me infinite solutions is if h is 2. And that's because I need to have the same number of x's and the same constants. Alright, let's take a look at the third example here, where we ask you to solve these equations. Let's take a look here. I'm going to distribute twice, and that gives me negative 24x minus 8. And over here, I'm going to distribute twice. I'm going to get negative 24x minus 8. And that's a perfect match. So this equation has infinite solutions. Let's take a look at our next one here. 32x minus 4 equals 4x minus 4. See these? These x values are different, so we will have an answer. We will have one solution and only one solution. And that solution will be, let's see, 32, let's do the math here. 32x minus 4 equals 4x minus 4. So I'm going to add 4x to both sides. 36x minus 4 equals minus 4, plus 4 to both sides. Oh, perfect. Less math to do. Divide by 36, and I'm going to get 0. So the only number that would work would be 0. So I'm going to type that here. And we're done. So this should feel familiar to you, solving these equations. So let's take a look here. After I distribute, I'm going to get negative 8x minus 12, and over here I'm going to get negative 8x. Oh, good. I got a matching coefficient here. Ooh, and matching constants. It's a perfect match, so that is infinitely many solutions. Done. Alright, let's go back. Take a look at the last one here. Express your answer in simplest form. They're getting longer and longer. So I've got negative 3x plus 6, and then the minus 9 is there. Nothing to distribute on the right. Negative 10x plus 7x minus 4. Now I've got some combining of like terms to do here. I'm going to get negative 3x minus 3 and negative 3x minus 4. Do you see it? I mean, we can keep going, but if you're paying attention, then you'll notice you have matching x values. And when you have matching x values and different constants, you have no solution. But just in case you were wondering, we can prove it here by adding 3x to both sides and seeing that this statement is not true. -3 can never be equal to -4. So this has no solutions. Alright, you're going to manipulate these equations. You can use your fraction button on your calculator if you need to. Now, pay close attention here so that you don't make any errors. This -3 is not touching the parentheses. This minus sign is. So technically, I'm distributing this invisible -1. So the -3 stays, and the invisible -1 is what's getting distributed. So the left side will be -3 minus 6x minus 9, and the right side will be -6x -6, and then minus 6 from outside. So combine here, we're going to get -6x minus 12 equals -6x minus 12. Are you paying attention? Do you see it already? Matching x's and matching constants, matching x's and matching constants. That's infinitely many solutions. Alright, that should be enough to get you going. Good luck.